Now that we have introduced interfaces in our lives, it's time to go back and think about the motivational example through which we started all the discussion. How can we solve the problem that we had with interfaces? Let me remind you briefly what the problem was, and for more details, go back to the short video that we had introduced this example. We want to have three classes: the bananas, eggs, and water class. Each of these classes will represent a supermarket cart item, so each of them has a price. However, all of them are quite different items. With the price, we calculate the price for bananas differently from a dozen of eggs or for a bottle of water. So each of these classes will have its own, get price method, for example, that will tell us how much we should pay for a particular item. Now, when we go to pay for everything in our supermarket cart, assuming we only have items from these three classes, we will need to have a get total method. But this get total method will need to combine the prices from all these different items in order to sum the result. How can we have an argument in the get.total method that will be able to represent any of these supermarket cart items? That was the problem. And again, I ask you to refer back if the description I just gave you did not really do it. Go and try to implement the solution and then come back to the video to see more details. Before that, let me just give you a hint. You can create, say, a register class, and inside that class have the getTotal method and your main method. And create an interface if you need one, and give it, for example, the name Priceable. This is the hint. Go and work on this exercise on your own and then come back to the video. Here is how we can implement a solution to the problem. First, we will look at each of the classes for the supermarket items: eggs, bananas, and water. All of them will have a constructor. You see the constructor for the eggs class here, and a getPrice method. The difference is that the way that getPrice is implemented differs vastly among the different supermarket items. So here, for example, for the eggs, we check whether we're talking about an extra large portion or of dozen eggs, or of just a large portion of dozen eggs. And you will see the constants, the price per dozen, large, and price per dozen, extra large, for example. If we go to the bananas, we will see that the get price is just the weight multiplied by the price per pound. Similarly, there is a constructor here, different kind of instance variables. That's why we have different classes for all of these items. And again, for the water, what we care about is the price per gallon and how many gallons of water are we buying. So you see the differences between all of these items. The important thing to realize, though, is that each of them will have a price when we buy it. The register class will be the one that will have the getTotal method, which computes, if we have a cart full of items, how much are we going to pay for all of them. And this is the important thing that we're introducing with interfaces. Instead of having as argument, for example, a variable that is of type eggs and a variable of type bananas and a variable of type water, we have an array of priceable items. How will that help us? You may have not noticed that here, each of these classes that I introduced, they are implementing this interface, the priceable interface. All three of them, the bananas and the water and the eggs. The priceable interface, all that it asks from the classes that implement it is that they provide a getPrice method. This ensures that when we write the getTotal method inside the register, and we just say that, the argument that I'm going to give you is going to be something that is priceable, that means that I can actually be sure that the getPrice method can be called on a priceable item. all of the classes that implement the Priceable interface will have this method implemented. So we can go ahead and call it. But the beauty of interfaces is that depending on what the particular object inside the Priceable array is, if it is of eggs type or bananas type or water type, the get price of the corresponding class will be invoked. So we will calculate the price based on the specific implementation of the class that the object belongs to. Let's take a look at what we do inside get total. Nothing really surprising. For each item in the cart, each item in the Priceable array, we are calling the get price for that particular item, and we are summing up all of the prices, and we're just returning the total. So there is nothing really complicated in the way that we have implemented get total. The only new part is the fact that we provide as argument something that is of type Priceable, and here it is a Priceable array. So how can we call the get total method? Let's take a look at main. We are creating, let's focus on line 14. We are creating an array of Priceable items. I know interfaces are new to our lives, but you may remember we have said that we cannot create objects that are of type interface. So the fact that Priceable, the name of an interface, comes after the new operator is a little bit weird, but we are not creating a class object, we are just creating an array here, an array that is of type Priceable. So what is not legal to do is to have Priceable P, this is legal, but then what we cannot do is go and create a Priceable object. You see this weird, probably for you, completion that IntelliJ just did for us. This is about an anonymous inner class when we will talk about it later. The IntelliJ IDEA completed that for us exactly because we cannot instantiate an interface. So the only thing that we could do with Priceable after new was what IntelliJ IDEA did automatically, create an anonymous inner class. But the point that I want to make here is that this is illegal. We cannot create objects that are of type Priceable. We can have interface variables, but not create objects through an interface. What we are doing on line 14, and it is perfectly fine, is that we are creating an array that is of type Priceable. And then we are populating the array with items, with elements. So at the position index 0, we have a bananas item. Position 1, we have eggs, an eggs item. Position 2, we have a water item. Different objects from different classes. All of them can be stored, although they belong to different classes, they can all be stored in an array that is of type Priceable. Finally, we just create a register class so that we can call through that the getTotal method with the items that are in our cart, these 3 items. And this concludes the discussion we had about the motivational example and how exactly an interface like Priceable allows us to write easily a method like getTotal.